Hello, everyone. I'm Jiankun. I am an assistant professor of operations management at Imperial College London. Today, I'm delighted to share our recent work on how forced intervention facilitates long-term algorithm adoption. This is a joint work with Xinyu Cao from CUHK, Chen Shanhu, and Dennis Zhang from WashU in St. Louis. We would like to thank Inform's Service Science Best Cluster Paper Competition Award Committee for selecting us as a finalist. So in human AI collaboration, it is very important for the humans to be willing to trust the algorithms and use the algorithms in a sustained manner because it can help generate more usage data, which can contribute to the continuous improvement of algorithm performance. However, in reality, algorithm aversion often exists, meaning that humans are averse to adopting algorithms. And this can be detrimental to the success of human algorithm collaboration. So how to facilitate long-term algorithm adoption and reduce algorithm aversion? The behavioral literature has shown the effectiveness of motivational or incentive-based interventions on reshaping humans' long-term behavior, but there's not much discussion about forced interventions. So in our study, we would like to examine, can forced intervention facilitate a long-term algorithm adoption and reduce algorithm aversion? And if so, what is the mechanism? We collaborate with an online education company that sells a package of one-on-one English classes. And here's their sales process. First, a potential customer or called a lead registers. And then the sales worker selects a teacher and books a trial class for the lead. And then the lead takes the trial class and decides whether they will purchase or not. In particular, the workers are free to use the algorithm for teacher selection or make the selections manually by themselves. And this is the focus of our study. So first, we find that the workers were averse to using the algorithm. The average algorithm usage ratio is relatively low. And besides, the workers tend to use it on more low-quality leads, who are those that come from marketing channels that by nature have a lower conversion rate than others. And also due to this selection bias, we observe that the algorithm has a lower conversion rate compared to the human selections. Then in 2019, we conducted a field experiment. In this experiment, the workers were randomly assigned to 3 groups. The algorithm group were forced to use the algorithm, and the control group were free to use the algorithm or not for teacher selection, and the manual group were forced not to use the algorithm. And after the experiment, all the workers are free to use the algorithm or not for teaching the selection. So the focus of our study is to compare the post-experiment algorithm usage performance between the algorithm group and the control group. And here are our main findings. First, we find that the forced intervention significantly increases the post-intervention algorithm usage ratio. And the increase is over 80% relatively. And this increase in the algorithm usage is not only driven by a few number of workers, but is rather prevalent across workers with various level of pre-intervention algorithm usage. And this increase in the algorithm usage is also not only driven by the few days after the experiment, and actually it remains quite stable over time after the experiment. The experiment also provides us with a fair comparison between the algorithm and human performance. In fact, we find that the algorithm does not perform worse than human. So this suggests that learning is possible in our case, meaning that the workers could possibly learn the unbiased good performance of the algorithm and update their belief about the algorithm positively through the experiment. So to test the existence of learning in our study, we first develop a theoretical model that incorporates both learning and habit formation, which are 2 mechanisms that may explain our results. And then based on this model, we derive a testing rule to identify learning while accounting for the possible existence of habit formation. The basic idea is that if learning exists, we should observe a positive correlation between the change in the conversion rate and change in the algorithm usage ratio for the workers in the algorithm group. So with our experiment data, we do observe a significant positive correlation between the two measures that we just mentioned in the algorithm group, but not in the control group. This suggests that learning exists in the algorithm group, meaning that workers in this group update their belief about the algorithm performance positively after the experiment. And another evidence for learning is that the workers in the algorithm group start to use the algorithm on more high-quality leads after the experiment. And this also contributes to a larger increase in the conversion rate of algorithm bookings after the experiment in the algorithm group compared to the control group. So to summarize the main results of our study, we find that the algorithm version exists in the sales process, and forcing the workers to use the algorithm for a period significantly increases their post-intervention algorithm usage. And the learning can be a mechanism explaining our results, meaning that the workers may update their beliefs about the algorithm positively, and as a result, they're more likely to use it on high-quality leads. So the major managerial implications of our findings that the firms can implement extrinsic interventions or education programs to help workers recognize the benefits of the algorithms and facilitate sustained usage. So this is our study. Thank you very much.